I did nothing but eat, breathe, sleep, maintenance and reliability for the last 12 years, but for the first year pretty intensively. And the thing that I found amazing was really how noble the maintenance guys are, because they're in an impossible situation that most of them have no control over how the equipment is being run, but when it breaks, they're suddenly at fault. It's their duty to fix it. And so I've been working on how do you change those behaviors, how do you help them move to a better state. And I'm standing here going to talk to you about several things that really, I'm standing on the shoulders of other giants who came before, like Jack Nicklaus Jr. And if you don't know Jack Nicklaus Jr., look him up. He's the guy who actually coined the term reliability-centered maintenance. He came from the Navy nukes program, and he was one of the team members that started the big push for thermal imaging, ultrasonic thickness, dye penetrant, all of these condition monitoring technologies that translated into $1.5 billion in avoided costs in the Navy sub maintenance program. And then there's Ron Moore, who's a lot of the work I'm going to talk about is Ron Moore. You guys might want to look at him. And then my personal favorite, a person who I'm honored to have as a colleague in our company, a guy named David Krings, and just some amazing people. So you guys might have seen this. This is Nolan and Heat. This is the first big look at different failure modes. And they looked at things where we think of the bathtub curve. If something fails in the beginning, then it runs great forever until the end of its life cycle. And the thing about this is, it's not true. It was cool, but they had all these randoms, right? Just random failure. Well, they're not random failures. Jack the Ripper lives in many plants. And he goes around stabbing things and killing things and murdering things. And that's the big thing that what we've been trying to find out where Jack the Ripper is, what is he doing, and how to get him out of the plant. So the thing about what equipment really experiences, actually if you've ever read the 5 Mistakes Plant Managers Make that Ben Lawrence wrote, and it talks about that P to F curve, but what you really have is, it was working fine, somebody fell asleep, they didn't run the pumps right, then they failed, and again, it goes back to maintenance. This pump failed, and you go, yeah, well, you can't run it dry for 19 hours. Sorry, the pumps just don't work like that. So there's various things that they go over. Another thing that's a big issue in industrial areas right now is the silver tsunami. Anybody heard of the silver tsunami? That's the retirements of all the guys with gray hair like me who are leaving with all this tribal knowledge. And that silver tsunami is wiping away hundreds of years of experience and knowledge. One of my clients in Pasadena, Texas has lost 232 years of experience when 5 guys left. 3 of them retired, 2 of them unfortunately passed away. Regardless, that experience is now gone and there's a hole in their plan. So one of the things we want to look at is how do we mitigate this type of stuff, because it's coming. So, often we say, like, what's safety? Is safety number 1? Right? I can barely see you guys, but please give us a little bit of feedback here. So safety is number 1, right? Okay. And safety is whose job? Everybody's, right? Great response. Whose job is reliability? It is everybody's, but what happens in your plant? Right? We know theoretically what it should be, but in actuality, it usually becomes maintenance. It's their job. Right? And it's their job by default because they're trying to figure out how in the world do I not have to go back and fix this thing for the 18th time in the last 6 months. So operations, procurement, engineering, and management all have an effect on reliability. It's just so much more than maintenance. So let's go over how maintenance, see, we're the last group. When it finally fails, everybody else looks at maintenance and says, all right, well, what are you doing? And you walk over and go, let me see what I can do to fix it. And it's heroic. It really is hard. I love the theme of the heroism of maintenance reliability people because they're put in an impossible situation where they have low control but all the responsibility. So reliability has to do with assets and systems designed for reliability, designed for the life cycle that they're undergoing right now. So design should be made for the ease of operations and the ease of maintenance. So last week we were actually pulling sensors off of a big system in Mont Belvieu, Texas. And the engineer went and pulled all of the sensors, came down and said, how was that? He goes, it's terrible. I had to go up 5 floors to cross a catwalk to go down 3 ladders just to get to the sensors. I said, yeah, I know. So glad you had to do that instead of me. It's only 99% humidity and 102 today. But the problem was, he said, yeah, he goes, I just saw a bid to put in ladders and staircases. It's $500,000 that they need to do today just for needed stuff. Because some design person said, well, I'll just put a ladder here instead of a staircase. And because there's no consequence to the design guy, he doesn't have to walk through a bunch of ladders to get to some equipment that he needs to get to immediately. And he saved the company hundreds of thousands of dollars yesterday, but he's going to cost them tens of millions of dollars in the future if they don't fix this stuff. So design for reliability. So here's an example. This is an old ODS, but this was a pump put in place. And long story short, what happened is when we talked to the design engineer, he said, why did you choose 1/4 inch thick plate for the skid for this pump? Because it's too weak for what this thing does. And what the construction company had done is, because it was vibrating too much, they bolted a turnbuckle to the sidewall, welded it to the pump, and then cranked the turnbuckle to tighten it over, and the vibration went down. They go, fixed. And maintenance said, oh no, if I have to change a seal, I have to get a vibration guy to go, 2 more turns, please. 1/4 turn. 1 more little bump. You know, I mean, you don't want to have somewhere you have to use a turnbuckle to keep the vibration down. So we went out and did this study and found out that they had just chosen too light or too thin a material for that particular pump. And when he found it out, the funny part was the pump and the motor were rocking back and forth, and the millwright said, "You find it?" He goes, "Yeah, if you put your thumb right by the foot there in the sole plate, you'll feel it vibrating." Well, he put his thumb right between the 2 pieces, and he got his thumb pinched. And he had a little blood blister. It's like, "Man, did you do that on purpose?" He goes, "No, I'm sorry." Sorry. Well, the maintenance manager came down because, "You guys find it?" The millwright went, "Put your thumb there." So again, design for reliability has a big aspect of affecting the long-term length and health of that equipment. Just from when we talk to the engineer privately, because you don't want to embarrass the guy, but you've delayed the entire wastewater treatment system from getting online because of your choice. Why did you choose that? And I say this often. It was Friday, he had a hot date, and he walked out of the shop and went, that should work. And he just chose a random piece that was fitting for his needs at the time, which was to get the heck out of there. And that happens. Acceptance testing is a big deal in our particular part of the world because you never know when Johan or Ming Huang or Jose or Peter, whoever, did they have a bad weekend, and Monday, they're not so good at putting that equipment together that day, right? So design for reliability is an important thing. We have hurricanes in the Gulf Coast of Texas, and we have some flooding. Hurricane Ike usually flooded about that much if you're next to the coast. And so this is a hurricane-proof, flood-proof building. So you can see right here, how do you move big, heavy equipment from these doors from the truck, right? You're like, really? You had to put that there? So they're going to modify that. That's not that big a deal. What you can't see, that I didn't have a good picture of, is to get your pumps and motors. These are pretty good size split case pumps. You actually have to remove the roof and put a huge crane in to lift it up and over, because these are actually in the basement. So they're not on the first floor here. So for the life of this equipment, they're going to spend an extra $50,000 to $70,000 every time they need to move a pump or a motor, just because of the design. Now, for operations, not in their budget. For procurement, not in their budget. But the maintenance manager is now saddled with this deficit to his budget every few years when he's got to move a piece of equipment because of this improper design. And maintenance, as you know, you guys fight for your dollars, right? So it's hard to say, great, I've got a new pump station, a new building, and I'm already down negative because of the design of the building. Procurement. Buying for cost is the wrong way to go. And procurement needs to understand the ramifications of their choices to go with this vendor who's got such a smoking deal versus that vendor over there that has the average price. When you buy for the cost of ownership, when you buy for the life cycle, you're going to get better results based on the information that came from your condition monitoring and your maintenance team. You guys know which guy has, or which product vendor has a better piece of equipment for you. If you don't, start experimenting and seeing. And that's some of the value that KCF has, is their ability to tell you, hey, we see the performance of this piece of equipment is much better than that piece of equipment. Maybe you should buy more of the stuff that has a better life cycle. So in this, you can see how the right side is pretty clear and the left side is kind of fuzzy. It's because that's spinning and that's not. And when my vibration analyst went in and talked to the control room, said, hey, this agitator isn't moving, they looked up, the motor amps are good. That thing's fine. Totally fine, right? So there's holes in the DCS and the PLC data that you get. They think if the amps are okay, the thing's okay.